Lesson 3.2, Angles and Parallel Lines. So in 3.1 we learned the names of certain groups of angles. Remember they were corresponding, consecutive interior, alternate interior, and then alternate exterior. Now in this lesson what we're going to do is learn the relationship of those if the lines are parallel. So a couple of things we want to point out here. First of all, how do you know lines are parallel? Well, there are two ways. First of all, they can use the parallel line symbol, which is the following. So if in a statement they tell you, go down here at the bottom, line N, and I can't draw in italics, and line L are parallel. So this is the symbol for parallel. Two up and down lines, vertical lines, line P are parallel. So that symbol. In a picture, the way they show that lines are parallel is right here with these arrows. And they typically use different colors if possible. Sometimes they can't if it's a printed page. So what you might see are just different types of arrows there. So the first thing you've got to know is they're parallel. Otherwise, these angle relationships do not exist. So what are the relationships? So we're going to go ahead and look at the different ones. Okay, so here we have alternate interiors, and you see they are congruent. Consecutive interior are supplementary. Alternate exterior are congruent. And then on the previous page we learned about corresponding, and corresponding are also congruent. Now that's the part we want to focus on. We're going to ignore the proof part. We're not worried about doing proofs here. We're just learning how to solve problems, really. So there are ways to build off of these, and these are called theorems, and then you learn corollaries too. But all this says is the perpendicular transversal theorem is that if two lines are parallel and a line is perpendicular to one of them, then it has to be perpendicular to the other. Well, what's that mean? That means every angle there is 90 degrees on both lines. It doesn't matter which line you pick. They're all 90 degrees. Okay, so now let's actually apply the relationships here with different examples. So if you need to, you go back and review, but what I'm going to do here is I'm going to come over here to the side, and I'm just going to write the relationships real quick, real brief here. So I'm going to say, I'm going to abbreviate here, corresponding or congruent, alternate interior are also congruent. Oops, wrong symbol. Congruent, okay. Alternate exterior, also congruent. And then the last one, consecutive interior. Those are supplementary, so I'm going to put add to equal 180 degrees. Okay, so in the figure, it says angle 1 is 94. So this is 94. So what I'm going to do before I answer any of the questions, I'm going to fill out the whole picture with angle measures. And I'm going to do that based on the fact that I know these two lines, again, are parallel. So I'm going to use all these relationships over here to write angle measures, and I'm going to use a different color. So I know angle 7 is 94 because those are vertical. I know angle 3 is 94 because 1 and 3 are corresponding. So if 3 is 94, then I know angle 5 is also 94 because 3 and 5 are vertical. And then because I know consecutive interiors are equal to 180, then I know angle 2 has to be 86. So I'm going to write 86 in here for angle 2, which means angle 8 is 86, which also means angle 6 is 86 because 2 and 6 are alternate interior, and I know they're congruent. And then angle 4 is 86. So I've got every angle here. So then all I have to do is look, okay, what's angle 3? So I go to my picture and look, angle 3 is 94 degrees. Angle 5, look at my picture, angle 5 is 94 degrees. My picture, angle 4 is 86 degrees. So I don't try to find just one angle. I try to fill in as much of the picture as possible, and then I answer the question. Okay, so let's do something similar here in the next group. It says angle 4 is 101. Okay, so where's angle 4? Angle 4 is right here, 101. So angle 2 is 101 because they're vertical. Angle 8 is 101. Oops. Because 2 and 8 are alternate exterior, or 4 and 8 are corresponding. And then angle 6 is 101 because 4 and 6 are alternate interior. Again, different relationships here to get different ones. So then that means angle 3 is 79. Angle 1, 79. 79 for angle 5, 79 for angle 7. So what do you notice here? Something you should pick up is that these always have to equal 180 because they're a linear pair. 180, 180, 180. Same goes true if you go this way. 180, 180, 180, 180. So then, what's angle 6? Angle 6 is 101. Angle 7 is 79. Angle 5 is 79. Alright, scroll down, find the value of the variables in each figure. Okay, so this is a little bit tougher because we now have to use a little bit of algebra here, but let's do this. First, let's take what we just talked about. These two are right beside each other on a line, so they have to equal 180. So I've got 180 minus 55, that's 125. So that's x. Again, because those two have to make a line or equal 180. Okay, so if x is 125, then what's y? Then that tells me y is also 125. Now, why is that? Because x and y are alternate interior. They're both on the inside, but they're on opposite sides. So alternate interior, I know we're congruent, going back to our theorems. Okay, what about the next problem? Well, look at my angles. These are alternate exteriors. They're both on the outside, one's on one side, one's on the other. So they alternate sides. What's the relationship for alternate exteriors when the lines are parallel? Alternate exteriors are congruent, or equal. So that's my equation. Add 10 to both sides, and that tells me angle, or x, not angle. X is 114. Alright, next. 2x plus or minus 15 is here. X plus 55 is here. Those are alternate interior. They're both on the inside of the two parallel lines. On the opposite sides, what's alternate interior? Alternate interiors are equal or congruent. So 2x minus 15 equals x plus 55. Subtract x. And get x minus 15 equals 55. Add 15. And then we get x is 70. So you've got to know these relationships, and then you've got to be able to solve equations again.